Hello, in this video we are going to try to learn the change of base formula, and also we are going to try to learn how to express a very large number in scientific notation. Okay, so let's first look at change of base formula. So let's say I have a logarithm of x base b. All right, now I want to basically express it into a different base. So let's say, so if I do that, so I'm going to write logarithm x as my numerator, and I'm going to write my logarithm b as my denominator. Okay, so once I do that, then let's say whatever base I choose, let's say if I choose a base a, then I'm going to write base a here. Okay, now so this is one way of expressing. Now let's say so this is any arbitrary base a. Now let's say I want to express it into a natural logarithm, so base 10. So it will be logarithm of x and logarithm of b. So remember, for natural logarithm I don't have to write the base 10, so this is base 10. Now let's say if I want to express it in natural logarithm, so I'm going to write ln x over ln b, so it is base e, so natural logarithm. Okay, so this is the formula for change of base. All right, so let's do a little problem so that it make our concept clear. So let's say we want to evaluate a logarithm of 13 base 5. Now in most of the calculator you will not be able to evaluate this expression, because in the most of the calculator you are going to have a logarithm either base 10 or base e. You're not going to have base 5, but some very high power calculator can evaluate this expression. But let's say so we are going to change it with a change of base. So first of all, let's say I'm going to use the natural logarithm, which is base 10. So it will be what? A logarithm of 13 over logarithm of 5. Now logarithm of 13 I can calculate it using any calculator. So if I do that, you are going to get, this is 1.1139 over, and if you punch logarithm 5 in a calculator, you are going to get 0.699, and once you evaluate this, you are going to get it is approximately approximately this is 1.59369. okay, so that's the approximate result. Now let's say instead of natural logarithm, I can try to solve the same problem, logarithm 13 base 5, using the natural logarithm. Natural logarithm, yes. So logarithm 13, natural logarithm 13 over natural logarithm 5. So this is going to be, if I punch the calculator, it is going to be 2.565 over 1.609. So if I punch calculator, I'm going to get approximately the same result, 1.59369. okay, so that's the same result. So these are some little application of change of formula, right? Now let's see, that is very important. Okay, so we want to express a very large number, which is 812 power 329 in a scientific notation. Okay, so we need to express this big number in a scientific notation. Now let's we do not know the answer. So what I'm going to do, I'm going to assume that that my scientific notation is basically my k. So let's say by my number k is equal to 812 power 329. Right, now what I am going to do, I am going to take logarithm on both sides. So what I am going to write is, I am going to write logarithm of k. So this is my common logarithm on both sides, and logarithm of 812 power 329. So common logarithm. All right, now see what I have is 812 power 329. So that power 329 can come in front of my logarithm. So I can write 329 logarithm of 812. Okay, so if I basically punch the calculator, I can get 329 multiplied by logarithm 812 is actually equal to 957.2439. all right, so and that is what equal to my logarithm of k. Remember, what is the base is 10. okay, this is a common logarithm. Okay, so this is what an logarithmic expression. Now if you remember, we learned that if I have a logarithmic expression, I can express it what into an equivalent exponential expression. So let's express this logarithmic expression into equivalent exponential expression. So I get k equals 10 power 957.2439. all right, now let's see how can I write. I can write 10 power, this expression equal to, I can write 0.2439 plus 957. all right, now I want to remind you about this formula. If I have a power x plus y, I can actually write it a power x multiplied by a power y. okay, so remember that formula. So similarly, what I have here, 10 power x plus y, so I can write 10 power x, which is 0.2439 multiplied by 10 power y, which is 957. Now if I punch the calculator to find 10 power 0.2439, I find it 1.7535 multiplied by 10 power 957. So this is my k. And what is my k? My k is 812 power 329. So this is 812 power 329. So that is the final result. So I am able to express a very large number in a scientific notation. okay, so that will be the end of this section.